The topic of today's webinar is how to fill holes using bridges and how to fill holes in general. So, hole filling basics. What is the hole filling in general? So, the hole filling is an intelligent feature that restores missing or incomplete scan data by interpolating the surrounding geometry to create a seamless and continuous surface. There are two main scenarios to deal with holes: fusion and fixed holes. Hole filling options you can find in the fusion, or you can go to the fixed holes. So, when to use hole filling in general? The decision whether or not to use hole filling tools entirely depends on the applications. It is critical to understand that a surface that was received by usage of hole filling tools, irrespectively, so whether it is fusion or fixed hole step, does not represent the real object. Thus, it is advisable to deactivate the hole filling for quality inspection applications. However, if you need to get a visual representation of the object, then the hole filling can compensate for surface or scanning technique inconsistencies. Possible applications include 3D printing, reverse engineering, of course, given that all critical areas that you plan to reverse engineer are actually scanned well, culture preservation, prosthesis, and many others. Let's start with the fusion. The easiest way to fix holes is to specify the hole filling parameter in the fusion algorithm. The options are following. The one that you can see on the screen now is watertight, where you cover all the holes, and the output is a watertight mesh. None, the mesh will have holes in all the areas with no data or low data density. As you can see here, there are several areas which are not covered by geometry exactly because of the mentioned reasons. This is the uh, this is the option that we recommend to use for quality inspection applications. In this case, you can be sure that if you are using, so if you are working with this mesh in the software like Geomagic Control X or Polyworks, then if you are measure something, you are sure that this surface is coming from actual scan data and not from the data that was invented by the algorithms of Artec Studio. Another option that has a great meaning for lots of industries is to specify the hole filling radius. So as you can see here on the screenshot, the option chosen here was that the radius under 5 millimeters to show you where it is located. So you can choose with the option with the radius under and specify the radius. In this case, you will get rid of very small holes, but the large areas which do not have scanned data, will remain uncovered. Later manually. This tool, so if you choose later manually from the options for hole filling in Fusion, in this case, you will the Fusion algorithm will offer you a list of uncovered areas, and you will be able to specify by clicking on this list which holes you would like to cover. Don't worry about the time required for the fixing holes in this particular scenario, because all the surfaces which will be covering the area will be calculated during the fusion algorithm. So the hole filling uh, in this particular option, the option which is called later manually, will happen instantly. Coming back to Artec Studio interface, there is an option which is called by relative radius, and this is the option that was invented with the purpose to be applied to combined projects. For example, for projects which involve array to Leo or Leo Spider 2 data. So in this case, the holes, the size of the holes to be covered will depend on the origin of the data. This is basically it when it comes to the fusion algorithm. As you can see, the functionality is pretty simple. And if your goal is to get uh, a, a watertight mesh for 3D printing, for example, then the easiest way is to choose all watertight and run Fusion. If you are using our scanners for quality inspection, then you just choose none, create a fusion uh, which will contain holes depending on the density and the absence of the scan data, and that will be it. However, we have another scenario which I will show you right away. This scenario is called fix holes. And in this scenario, we will be working with the mesh. So I'll go to fix holes. And once I access this tab, I am provided with the whole and comprehensive list of holes. As you can see, I have quite a lot of them. And let's check how this tool works. So let's take a look at this little hole. You can see that the surrounding area is rather flat. In this case, this is a perfect scenario to employ filling mode, which is called flat. So once I choose this hole in the user interface, I am automatically, so Artec Studio automatically indicates this exact hole from the list. I can choose flat, fix holes, and that is it. A very fast and very straightforward way uh, to close holes on the planar surfaces. Let's take a look at this hole. As you can see, this surface is not planar, but the shape is still quite simple. So it's quite easy to predict how this area will look like. So exactly for these cases, we have another mode, which is called smooth. So let me click on this hole, fill holes. You can see that due to the fact that this is quite a simple surface, uh, this algorithm is doing a pretty good job covering this hole. So the logic here is pretty straightforward. Um, Algorithm analyzes surrounding area and tries to continue the surfaces from all the edges until they meet at a certain point. This is exactly what we have here. As you can see here, if we observe the profile, you can see that it is it is covered pretty well. However, sometimes we can find ourselves in a situation where we have a more complex hull, for example, this one. Let's check how the smooth hull filling deals with this one. Well, I would say it's not bad, but I cannot say that it is good either. So um, probably here we need to use something more sophisticated. And by sophisticated, I mean the tool which is called bridges. So for the holes which contain pretty diverse geometry, such as steps, um, corners, edges, and so on and so forth, it's good. The best practice is to use bridges. So let's observe how to do it. First, we need to click on the hole. Let me orient the part this way. But before we do it, it's a good idea to make the edges of this hole smoother. So I'll go to Edges. I choose this hole. And you can see that this green line gives me a prediction of the edge of this hole, which will be effective once I smooth the edge. You can play with the smoothing strength slider. So if I go to the smaller values, you can see that it basically, so the shape of the final edge will be closer to the original one and vice versa. Uh, me personally, I almost never choose the default value, but again, uh, you can uh, you can check what is the best way for your particular scenario. So I click on Smooth Edges. Perfect. You can see that now the hole is smooth, and it means that I can go and use bridges. So what is the bridge? The bridge is is a surface uh, which I will be using for the referencing in the most complicated area. So for example, here I will connect these two parts of the step. I can adjust these two little spheres. And this is the prediction that I will have, that this is the shape that I will have once the bridge is constructed. The beauty of this tool is that here we can actually change significantly the shape of this bridge. So by playing with these sliders, first edge curvature and second edge curvature, I can adjust the shape of this edge. And I can adjust it in a way that suits my particular application. So in other words, it is basically a very modest, but still it is a 3D modeling, which gives you the possibility to create a surface, of course, in the limits of the edge curvature tool. So once you adjust it, you click on Build Bridge. And voila, here is the bridge. And now we basically covered with the bridge the most complicated part, the step. As you can see here, the change between one diameter to another diameter. And now these two holes can be closed pretty easily with the standard uh, hole filling mode. So you can see that now the shape is way better and way more complicated, thanks to the functionality of the bridge. Of course, as I already mentioned, it won't be a good idea to use this mesh with this artificial edge for quality inspection, for example, because, of course, there's no particular sense to measure this part, which is not taken by the actual measurement, but which was recreated using the 3D modeling. However, if you need to recreate some surface for referencing, or if you want to complete the surface in order to 3D print it, this could be a pretty good solution. Generally, if you want to make this area less pronounced, you can work a bit with the editor, more specifically with the smoothing brush. So with the smoothing brush, you can change the, you can smooth the area where you played with the bridges, and after that it will be pretty unnoticeable. Another thing that it is crucial to remember is that when you are working with bridges, it's better, and by better, I mean way better, to use uh, short and wide bridges rather than thin and long bridges. I will illustrate it using another project. So, as you can see here, this is a very long and pretty narrow hole. And let's check what could be the problem here. So we go to fix holes. Let's smooth the edge first. And go to bridges. So let me try to connect this edge with its counterpart. As you can see, due to the fact that the area that I'm aiming to cover is quite long, then the edges will be quite crazy. And this is exactly the situation that you want to avoid, because you definitely don't want to have the surface of the bridge intersecting with the real geometry, because it will be pretty hard uh, to use in your further application. So instead of this approach, I recommend to uh, create short but wide bridges. In this case, you can get way better shapes playing with the curvature tool. So, for example, I can make it almost 90 degrees. Here, almost 90 degrees. Build bridge. And voila. Here, I mean, it is not it is not perfect 90 degrees, but it at least something, and it is way better than any other option that you have in Artec Studio. Of course, the best option to cover the holes will be to use the fusion algorithm, but sometimes you just have if you want to model some surfaces, or if you are working with the mesh which you received from another person, or if you are working with a mesh from third-party scanner, these tools could be pretty helpful when it comes to modeling and hole covering. So once again, it is possible to fix holes outside of the fusion algorithm. It makes sense to use this tool in two scenarios: when you are working with a third-party mesh, or with a mesh for which you don't have the scan data, if you are aiming to model surfaces instead of regular hole filling by using bridges. So that is basically it, what I wanted to share with you today. This tool has been in Artec Studio for quite a long time, but it's still a good tool, and sometimes applications or scenarios come up where bridges could be pretty handy. So, thank you for watching this webinar.